Good afternoon, everybody. Thank you for joining this training presentation, which is on sub-slab soil vapor sampling using sampling kits provided by the SGS laboratory. Vapor intrusion occurs when vapors from volatile chemicals in contaminated soil or groundwater migrate through subsurface soils and impact the indoor air quality of overlying buildings. Soil vapor sampling involves the collection of a sample, which is usually through a hole that is drilled in the concrete slab on the ground floor of a building. Common chemicals of concern for vapor intrusion are volatile organic compounds. US EPA method TO15 specifies the use of specially cleaned and evacuated canisters for soil vapor sampling. Canisters are evacuated, and it is this vacuum that is used to draw the sample into the canister. The flow rate at which the sample is collected is regulated by a flow controller. The sampling train consists of the canister, the flow controller, and a vacuum gauge. The entire sampling train is prepared by the laboratory, and it is this that is requested by consultants. Following sampling, the entire sampling train is then returned to the laboratory. The canisters are analyzed by GCMS. This presentation describes a procedure for sample collection using sample kits provided by the SGS laboratory. In terms of equipment, the laboratory will provide the following. The laboratory will provide a certified canister as well as a flow controller. They will also provide a length of 1/4-inch Teflon tubing, which connects on one end to the inlet of the flow controller, and on the other end to a swage lock valve, which is used to isolate the sampling train. The lab will also supply a 60 milliliter disposable syringe, which is used for purging of the sampling train. The laboratory will also supply chain of custody documentation, which will need to be completed and submitted together with samples that are sent to the laboratory. The consultant will need to supply a short piece of 1/4-inch Teflon tubing, which will connect to the sampling point, as well as all other materials required for sampling. Upon receipt of the equipment from the laboratory, the first thing that a consultant will do is unpack the canister and unpack the flow controller. Consultants will record the individual tag numbers for the canister as well as for the flow controller. These are recorded on the field sheets and chain of custody forms. You will then need to remove the brass cap from the inlet of the canister and connect the flow controller using an adjustable or a 9/16-inch wrench. Ensuring that the inlet to the flow controller remains sealed, it is also a good idea to check the initial canister vacuum. This should be approximately -25 to -30 inches of mercury. This is merely done by opening the canister valve and observing the vacuum gauge. A canister with significantly different pressure than originally recorded by the laboratory should be replaced and not used for sampling. This diagram shows an overview of the sampling setup. The inlet of the flow controller is connected to a length of Teflon tubing, which is connected to a two-way valve. A short piece of Teflon tubing is then connected from the valve to the sampling point. Prior to sampling, it is necessary to purge the sample line. Purging of the sampling line is performed to remove ambient air and to ensure that samples collected are representative of subsurface condition. Any ambient air in the sampling line could dilute the sample. In order to do this, we attach the Teflon tubing from the sample point to one side of the swage lock valve. We then attach the laboratory supplied Teflon sampling line to the other side of the two-way valve. We attach the 60 milliliter disposable syringe to the open end of the sampling line. We now ensure that the swage lock valve is in the open position, and we slowly draw back on the syringe to obtain the desired purge volume. Purge volumes for sample locations should be 3 times the volume of tubing. As an indication, for a 1/4 inch piece of tubing, this corresponds to 50 milliliters per meter. Once purging is complete, we ensure that the two-way valve is in the closed position. As an alternative to using a syringe, you can attach a sampling pump that is calibrated to a flow rate of less than 200 milliliters per minute to the sampling line and follow the same procedure. Once we have purged the sample line, we then check the sampling train for any leaks. All fittings between the two-way valve and the canister must be airtight, or ambient air can leak into the canister and significantly bias the measured results. With the two-way valve still in the closed position, we remove the cap from the inlet to the flow controller, and we attach the Teflon sampling line to the sampling train. We then open the canister main valve to apply a vacuum to the sampling train. The vacuum, as read from the sampling gauge, should remain steady for 1 minute. If this occurs, the sampling train can be considered to be adequately tight. The start and end vacuum should then be recorded and reported. A loss of vacuum indicates a leak, and all the fittings should be tightened until the sampling line can hold a vacuum. We are now ready to collect the sample. Sampling is initiated by opening the main valve and then opening the two-way valve, thereby ensuring the free flow of vapor from the sampling point to the canister. At this time, we record the initial canister vacuum and the start time on the field data sheets and chain of custody. We then monitor the vacuum gauge on the soil vapor tray. As sampling occurs, the canister vacuum gauge should slowly decrease. Flow rates are set for the flow controller by the laboratory and cannot be adjusted in the field. As an example, a flow rate of 200 milliliters per minute equates to approximately 5 minutes worth of sampling for a 1 liter canister. Remember, sampling should always stop with a residual vacuum, approximately 5 inches of mercury in the canister. This is the quality controls step to check for leaks between the field and when canisters are received in the laboratory. When we have finished sampling, we record the residual vacuum as well as the stop time on the field data sheets and the chain of custody. We then remove the flow controller from the canister and replace the protective brass cap on the canister. At the end of sampling, the following information should be recorded on dedicated sample collection forms. Firstly, we need to record the unique sample ID for the sample location. We record the canister ID. The canister ID should be consistent with the label that was supplied with the canister. We note the date at which the canister was cleaned. We record the initial canister vacuum. We note the start date and the start time. We also note whether a leak check was performed or not and whether the leak check was successful. We record the canister vacuum upon retrieval, and then we also note any sampling comments. In other words, any factors that may have impacted upon the sampling results. So, for example, staining in close proximity to the sample point. Remember, all samples should be shipped to the laboratory under full chain of custody documentation, including the required analyses to be performed. Canisters are also expensive and they are fragile. So canisters should be handled with care to ensure that the interior surface is not compromised, the valve connection remains intact, and that the weld integrity is maintained. Canisters should be shipped together with the sampling train in protective hard shell boxes to ensure sample integrity. Upon receipt in the laboratory, the samples will be registered. the sampling information will be validated. In other words, the laboratory will validate that the start and stop times are reasonable and that the start and ending sample pressures are unexpected, and the laboratory will also verify the canister pressure. I hope that it was useful, and if you have any questions, please do not hesitate to ask them now. Otherwise, thank you very much for attending this presentation.